G'day everyone, welcome back. I'm going to try and make another 2 videos tonight. It's 9:34 now. But seeing as it's the weekend, I'm going to use that time to my advantage and try and get as many videos made so that when I'm at work or I'm busy during the week, I can upload those videos so that there's still new content every day. Because I found that really I'm trying to get the channel going like like crazy, you know. I'm trying to build it from nothing to something as fast as I can, and well, yeah, I'm trying to get videos up every day and upload shorts and upload stuff to Instagram and TikTok to try and bring people into my YouTube channel. With that being said, if anyone likes my sort of content, electronics, design, repair, research, modifications, builds, whatever, please like and subscribe, because I'm a new channel and I'm trying to get out there, but I'm also not the sort of person to sit there in every video and be like, please like and subscribe. It just feels weird. So yeah, with that being said, this is the e-bike that I was talking about when I fixed the other e-bike. I said that my mate had another e-bike with different problems. I think this is a slightly different colour. I can't remember what colour the other one was. I think it was black. Sorry, I just had to peel that off the display. I don't think he's noticed. Anyway, this is the one where the whole bike works. Oh, and the other thing I want to point out quickly, that other e-bike, I'll just turn this one on quickly. This one's problem is it works, but as you can see, the display comes on, but it doesn't light up. Now, the other one, it turns out if you hold the up button, the headlight comes on. Alright, and that worked on the other one, so everything worked on the other bike. So I'm just having a look. There's 4 little screws on the back of this. This little screwdriver should do. So we're going to get this screen unit open. So with this one, the backlight's not working. We don't know what it is yet. So could be a wire that's come unsoldered, an LED that's come unsoldered, a dropper resistor for some LEDs that's got a cracked solder joint. It could be a little boost converter PWM module that drives the backlight that's failed. It could be a number of things. So we're just going to have to open it up and do some testing. I've just turned the screen forward so that you guys can see. Right. Oh, that's still switched on. Just turn that off. The next challenge is working out how to get into it. Just cracked a very small bit of plastic. It seems that this plastic is glued down with some glue, so I'm gonna have to heat it up, but I don't want to damage the plastic, so let's going to set the temperature as low as it will go, down to 100 degrees. I'll start at one end first actually, and see if this is even a plausible idea. Not really. Yeah, the whole thing is definitely glued down. Let's get a razor blade. Try and go around the edge. Ah, that works. Right. Okay. Just have to use our noggin. There we go. That's that off. That actually worked out well because I used the razor blade to cut the foam. It's cut perfectly in half, and I'll be able to put a nice layer of contact cement or something like that around it and get it back together. Alright, now there seems to be two little screws holding the board in. Very small screws. And there's cables coming in from the back, so we're going to have to feed the cables in order to lift the board up. You can already see that. I've only opened up one of these, or maybe two of these units before. Okay, so the wires are glued, so I'm not going to be able to get any more cable in than what's already there basically. I'll just try and tilt this around a bit more. That should stay like that. Alright, where is the backlight? So the backlight's up the top here, under this white. So it's those two tabs there. Those are for the backlight, those bottom two tabs. Alright, what I'm going to do, let's see if there's any voltage present. Going to the backlight. How am I going to get all this in focus? No. I'll turn the unit on. Right, it's on. And I'll hold my meter. You guys can see the screen yet? You guys can see the screen. Okay, so there's absolutely no voltage going to that backlight. So it's not the backlight itself. Okay. it's on, as you can see. No excessively hot components. Alright, well, I'll turn that off. I need to take the battery off to disconnect power. I'm just hoping that the battery's unlocked. Because, okay, the battery's unlocked, good. And I'll just hit the power button. Yep, you see that? There was still some residual charge left in the capacitors in here. That's why I hit the power button, to drain that power away too. So we don't short anything in here, and we don't want to get false readings when we go to test our components. First thing I'm going to do is I'm just going to put my meter in voltage mode again, and I just want to look across a couple of regulators and transistors to see if there's any voltages present, chips, anything, capacitors. The reason for this is because I'm going to go and test a whole bunch of transistors and FETs, whatever they are, on this board, and if there's any voltage present, it'll throw the readings off. So I want to make sure this is discharged. So yeah, it's dead. So now we'll go to diode mode. So that tests like a MOSFET. So it's bloody awkward probing a board like this. That's a transistor. One second. I just want to compare the markings on those two devices just to make sure that that first one is a MOSFET. Oh hey. Okay, we might have already found our problem. So these components are both marked G1. Yeah, G1. There's one's C1 and one's G1. No, they're both G1. So the fact that one of them is reading 2 diode junctions and the other one's only reading 1 is already suspicious. Let's keep going anyway. There's a TL431, well it's not that. Alright, we'll go test the rest of these transistors. Yeah, that one's good. You know what? These all test good, except for this one down the bottom there. I think we've already found out what's wrong with this. That small little surface mount transistor is not working. Alright. Oh. I thought I'd put my hot air off and it was just sitting there. Okay, so I'm gonna have to remove that. It's in an awkward spot. I think I'll be alright. Get a hot air, set the temperature on that. Right, back up to 420 for a sec. And I'm just going to remove just this one transistor. So I've got the transistor now. That's it there. Oh, sorry. Can't really get my camera to focus for it. There we go. Okay. I'm just going to test this on the bench out of circuit quickly. I know you guys can't see this. I'm sorry. Oh, what? Out of circuit. It tests good. Huh? Was that transistor cooked and the heat fixed it? Obviously not fixed it, temporarily fixed it. It's going to break again. I'm wondering. I think what I'm going to do, I'm just going to grab a little SMD breakout board. For this SOT23 device, little breakout board here. I'm going to stick that in a breadboard. Like so. Let's see if I can turn the camera around. Okay, that works. Alright, I'm just going to take this transistor and solder it to this breakout board. And then I can use the DCA Pro 75 and find out exactly what its characteristics are. And then I can go replace it. Okay, we got contact on all 3 pins. So now that allows me to test that component. So I'll just get the DCA Pro. Damn. Trying to get it so you guys can see the screen, but Yeah, sorry about that. I don't think you guys are going to be able to see the screen. Maybe if I shine a light on the screen. No, that just makes it worse. Yeah, don't know what to do about that. The only thing I could do is connect it to my computer and show you it on the computer screen. Anyways, it's come up as an NPN. So the red one, this pin's the collector, the green one is the base, and the blue one is the emitter. It's got an HFE of 172 with a collector current of 5.05 milliamps, VBE 0.680 volts with base current of 1 milliamp. At 5 milliamps, it's gone up to 0.747 volt. You know what? This is behaving completely normal. VC sat is 0.035. I'm wondering if there was just a bit of crap on the board and my multimeter probe just couldn't make contact with that transistor. I think I'll put it back on the board for now. I mean, I guess if we put this back on the board, right, and all of a sudden the thing works, it's a pretty good indication that that transistor's faulty. So but I got a funny feeling that there was just some oxidation on there and it just couldn't get contact with my meter. Alright. Oh, I'm going to have to clean the pads up. That'll do. I'll just grab the transistor with a pair of tweezers and I'll tack it. I'll tack it down first and then I'll come back and solder it. I just dropped it. Might have to get a little bit of flux on the board or something. Oh, I think I got it. I think I just about got it. No. Alright, I'm going to have to get something on the board, like a drop of flux, just to hold the transistor down, actually, not to make it clean. Actually, you know what? That flux is really runny. I want something thick. I've got some proper rosin flux too. Just trying to find something to use. I use the resistor leg. Put a drop of that on the board. The transistor will have something to stick to whilst I go to solder it. There we go. Don't ever use plumbing flux on circuit boards, guys. You can get rosin form solder, especially for electronics. That's what you got to use. Do not take plumber's flux to a circuit board. It is corrosive and it will destroy everything. And when I say destroy everything, I mean destroy everything. God, this is a tricky one. Okay, I think I can get that. Yep, there we go. It was a little bit hard to get in there, but I got it. Just out of curiosity, does it magically work now that I've taken that out and put it back in? Or was it just a dirty connection when I tested it on the board and it didn't test? Or is it because it's in circuit? No. Still no light. Okay. This is an interesting one. Well, let's start checking diodes. The backlight's dimmed. You know what I'm going to do? I'm just going to buzz out and see what the backlight connects to, because I don't know what's... You can set it to 5 different brightness levels, so obviously something dims it. Let's just see what it goes to. It must just be power. Like, sorry, common, like ground. Let me just verify that. No. Is it the output of a regulator? No. Is it driven by the micro? I wouldn't think this would be able to source enough current for it. It's got to be one of these transistors. Not having much luck here. Can't seem to find what it goes to. I'm just going to take a toilet break because I really need to go to the toilet. I have to think about that. Maybe there's a dropper resistor somewhere. That's alright, I'll be back in a minute. Alright, so I'm back. I'm just going to check over some resistors because there's probably a dropper resistor in series with the LED, and you know how it is with everything these days. They always undersize components. Actually, you know what? I see one that looks a bit dark. I wouldn't be surprised if there's a resistor running really, really hot with the backlight current going through it and the resistor's going to open. Would not be surprised. Nothing would surprise me. So, it's going to be a low value resistor. It's most likely going to be down in this section. I can also read the numbers on these chips quickly. So that one there's 24CO4 flash. That's obviously the micro. So we know that's flash memory. We know that's the micro. There's a little boost converter here now. Oh, DY, that's a transistor. I thought that was... Hold on, I thought that was a voltage regulator. I'm pretty sure that's a transistor. Hold on, let me just test it. What? So it's like a normal transistor between two pins, but I thought that was shorted. Okay, so that's a transistor. Nothing wrong there either. What about the diode? Wait, what? Is that a diode or is that a inductor? Oh! I think that's supposed to be a diode. Hold on. R48 Q9D9. No, I think that's an inductor. There's no like marking on one end versus the other end to say to you that it's a diode. Well, let's just keep on testing what we can test. I can't see any low value resistors, by the way. That diode's good. That's good. That's good. Hey. Oh, I'm an idiot. I am an idiot. I've got the battery in it. Well, no wonder everything's reading funny. There's voltage on the board. I'll just drain that out again. I can't believe I did that. Hey, could be worse. I could have shorted something out. Right. Well, it does test short that way. Hold on. Yeah, only in one direction, but okay. And that way it doesn't test short. Well, there's no more diodes. Oh, that's a capacitor. Okay, that's what that is. Yeah, that's a capacitor. Okay. Making slight progress. We're going to have to find what drives the backlight. So let's go test against capacitors. This is a tricky one. If anyone's wondering why I've tested over a couple of transistors twice, it's just because I'm not sure I've made perfect contact on every pin. So I just wanted to double check. Aha. There we go. Wait. What? Okay, so that transistor drives the LED. And it's continuity to it. What's the other side go to? Ground. Yeah, that doesn't really make sense. Oh, okay, that's just... No, for the life of me, cannot see what this backlight goes to. I've worked out that that's the positive side of it, I think. I just don't understand this. I can't trace the backlight back to anything. This is crazy. There's no break in the trace, isn't there? No. This is insane. I'm just going to double check one more time, but there's definitely no power present to the backlight itself. Maybe my probes weren't actually making good contact when I tested it the first time. I'm just going to power it up again. No, nothing. And take some measurements whilst it's on. So that's the battery, that's 50 volts. That's also the battery, I think. Yep, 51.5 volts. 5-volt rails up and running. So it's definitely negative. I wonder if it is being powered from the microcontroller. Because the backlight goes off to these two vias just there, which go inside the board, and I don't know where they pop back out. Actually, let's just See if we can find where one of them pops out even. This is crazy. I think this is a fairly common controller. All I can do is stop the video here and go and have a look and see if I can find the schematic or anything on this controller. Because, I mean, at the moment, I can't even trace what the backlight goes back to. I'll just go over some of the resistors quickly. Not any high value ones, obviously. Man, all the low value resistors are reading good too. So that's the micro, that's the flash memory, and that's the switch mode controller for that inductor, that diode, and those three capacitors. So that's your 5-volt supply there. That's your flash memory. That's your microcontroller. That only leaves these surrounding components, and nothing buzzes out to either of these two pads that goes to the display. So all I can do is go and get a data sheet if I can find one, or a schematic or whatever. If I can, I will come back and finish the video. If not, I guess I might just upload it as it is. I mean, I don't know what to say. I'll stop this for now anyway, and I'll go see what I can dig up and I'll come back. Alright, so I've come up with a solution for the display backlight. I've sat here, I've measured across the resistors again. I've tried to trace points out. I cannot find where either of the backlight points, they disappear to two vias there that go into the inside layer of the board, and I can't tell where they come out. With that being said, all the transistors test good. Everything tests good, and there isn't a like LED controller chip. So here's what I'm going to do. I'm going to cut the two traces where they connect down the bottom here. I think I might just grab my Dremel for this. And isolate the backlight from its driving circuitry. And I'm going to power it with a dropper resistor from the 5-volt rail. So we're just going to basically disconnect it from the circuit that powers it that's not working, and reconnect it to 5 volts with a dropper resistor. And we'll just choose the resistor value so that it's not too bright. Obviously it's not just about the brightness, it's about not burning out the LEDs. So that's the backlight completely isolated from its driving circuitry. I'm just looking up here because earlier on I tossed a couple of little small bits of wire somewhere that will be really handy for what I want to do now. Oh, well, who cares? We'll just use more wire. Alright, so I just want to double check the polarity of the display. Oh, perfect. Got some AA batteries here, can link up at 3 volts. There we go. Alright, so we know positive's on the left actually. Just double check that. Yeah, positive's on the left. Okay, so we'll grab a couple of little bits of wire. Okay, that's perfect. Like that. That'll do nicely. I'll just restrict the ends on it because it's a bit ugly. And what do you know, my soldering iron's asleep. I mean, that's to be expected this time because I have been out of the room for a bit, but yeah. It's always asleep when I need it. Got my piece of wire, or should I say wires? There's 2 of them. I'll just move you guys down for a sec so you can see. We're just going to tin the wires. And then trim them up a little bit. Alright. Now, positive was on the left. Just bring you guys back over to the bike. Excuse me. Alright, positive was on the left. Just flow some nice leaded solder into that. The pins that are coming through the board don't even accept solder. Wow. I don't even know what that is. Alright, positive's on the left. Negatives on the right. Now what we need to do is we need to get power we need to find our 5-volt rail. I already know where the 5-volt rail is, I just don't know which is positive and which is negative. Right, that's on. Stick the meter like that again. Can you see it? There you can. So these capacitors up here are going to be the 5-volt rail. Six point something. I'm getting worried I'm going to short something out. I'm just going to put the meter on the bench and just do this the comfortable way so I don't risk blowing up. .4 volts. I would have thought it would have been 5 volts. Let me just check a few other things. You know, it's 6.4 volts. Okay, well, 6.4 volts. So which side was positive and which was negative? So positive is on the top. Yeah, positive's on the top, okay. Alright. Well, that can come off. So what we'll do first is we'll take the negative wire I'm going to need to cut this. I think I'll make them separate. Take the negative wire, we're just going to solder that straight to the bottom obviously. That's basically the ground point. Okay. So that's just going to live there, like that. That 6.4 volts isn't there all the time, is it? Surely that boost converter wouldn't run idle. I'll just make sure, because otherwise I can't hook the fan up, the light up to that if there's always power there, because when he turns the bike off, the light, the screen will still be on. No, it's dead when it's off. Okay, that's good. Alright, so I'll turn it on. You know, I could honestly just pause the video and get my calculator out on the phone and do the math, but I know the ballpark I need to be in. So I'm just going to start. 1K. That's what I'm going to use. It's a perfect brightness. It's not too bright, not too dim. Alright. 1K resistor. So now, I'll take the battery out first before I blow everything up in my face. 48 volts DC. Won't be nice. I'm just going to make sure that these capacitors are all actually in parallel. Okay, they are cool. That's good because I can use the back of all three of them to support one leg of the resistor off of. No, that'll be fine. Alright. Now, I need to work out... I need to get some heat shrink on the resistor's leg for starters. Maybe some spaghetti tubing. No, I used the heat shrink. Not a lot. I'll just shrink that bit of heat shrink over the resistor, or the resistor's leg. Alright. That wasn't a good signal. I'm just going to crop the leg and tin it. Actually, want it that more. Alright, I'm just going to tin this resistor. I was just going to move the phone down for you to watch, but I mean, it's not really worth it just for me to tin one resistor leg. Oh. Alright, so I'm going to place that along the back of those three capacitors and solder it to them. Like so. The N1 needs just a little bit more solder. Perfect. So now I've got my resistor there and the heat shrink. I can bring it round without it shorting against any other components. Plenty of clearance. And then I can crop the leg real short up against the butt of the resistor, like so. And then I can tin that leg. Alright. Get a tiny little bit of heat shrink. Also cut that wire to length. Get a tiny little bit of heat shrink. And actually I'll cut it a bit longer so I can slide it over the whole resistor. Add some more insulation. I'm gonna have to strip that wire first. Alright. We'll tin that wire, then we'll put the heat shrink over it, and then we'll solder it to the resistor, and then we'll heat shrink it up. Cool. Now we'll try and get this heat shrink over the resistor as well. Okay, it's not going to go over the resistor, but it's at least over the end of it. I'm happy with that. And there we have it. An alternative method of lighting the backlight. I wasn't going to let it defeat me. Once I realised that it was fucked beyond repair, I said, well, that's alright, I'll just redo the backlight. Let's give it a whirl. Look at that. Just what you want. So obviously you can't adjust the backlight brightness no more, but there is a backlight. I hope my mate's happy. Oh, you're not supposed to put glue on that. It's like this foam. It's a press fit foam. So you screw the screen in, and then when you screw the cover down, it presses against the foam, creating an extra seal. Well, might have spent a while trying to fix it properly so it was still dimmable, but I guess that was a waste of time. It's funny how long you can spend working out what you're going to do with something, and then when you go to do what you're going to do, that ends up taking like 5 minutes, like what we just did there. So it goes like that. And this goes over the top. Right, cool. Yeah, okay, no, that doesn't seal it. I'm going to put some glue around that. I want to get this on camera, but I also don't want to make a mess and get glue everywhere. Alright, that's plenty. Well, it's well sealed now. Won't be any water ever getting in there. understand this cover. It's a weird fit. It barely fits. Alright. That screw is already threaded and I did not do that. Well, there we go. I think he's going to be happy. Alright. I'll see you in the next video, guys. Take care.